Welcome to the Golden Gate Area Council STEM Activity Series brought to you by the Golden Gate Area Council STEM Committee. My name is Caroline Suyuki, and in today's experiment, we are going to test just how hard your tap water is. In order to test how hard your tap water is, we first have to start talking about something else, and that is soap scum. Have you ever seen soap scum? This is the stuff that ends up getting stuck in your bathtub or clouding up your shower door. And you're probably wondering, is it because I'm so dirty? Or am I using the wrong soap that I get this soap scum? It's neither of those. It really is about the water that comes out of your faucet. Let's think about where water comes from. When you turn on the tap, where exactly does your water come from? We're all over the United States and all over the world, water comes from different sources. In some places, water comes from a beautiful mountain spring. Sometimes water comes from rivers. These are all natural water sources. In some places, water is collected in reservoirs. And then again, in certain parts of the world, they can actually take seawater and desalinate it in order to turn the water into something that is usable for every day. For a lot of people in the United States, water comes from deep wells. We use a pump to bring water from deep aquifers onto the surface for our own use. But wherever your water comes from, the amount of metals and minerals in that water will be different. And that is what we want to test today. The materials for this lab are water samples from various sources. So all the scouts have to bring different water samples. You want to have a sample of purified water. That can be distilled water that you can purchase or make. Or if you go into the store and look at some bottled waters, you can look at the label and find the ones that are actually purified by a process called reverse osmosis. Those waters will count as a sample of purified water. You also want to have a sample of Castile soap. Now, Castile soap comes in these very large containers. And the reason that you want to use Castile soap is because it is a pure soap, no perfumes, no special added stuff to it. It's just soap. And that's exactly what we want. You want to have some clear cups in order to do your experiments in, a few stir bars so that you can mix the soap in with the water. And you want to have a plastic pipette or a medicine dropper to dispense your Castile soap. We are going to switch on the document camera to show you how to actually run this experiment. So cub leaders, after we do the demo, it would be a good time to pause this video so that you allow your cubs to actually complete this experiment. So here I have my experimental setup. I'm just using glasses from my cupboard, but I have 3 samples of water. I have the purified water. This is water that I bought as bottled water, but this water just happened to be purified by reverse osmosis. That's what it looks like. I have tap water that just came from the faucet from where I live in the city of Lafayette in California. And then I have a sample of spring water. This is actually bottled water, but I noticed that it is not purified by reverse osmosis. And it was isolated. It was actually retrieved from fresh mountain springs in Northern California. So we're going to test these 3 waters. And all I really need to do is add a few drops of Castile soap to each one of my water samples. So here's my pipette. I have a sample of the soap in this little bottle right here. And I'm going to add a little bit to the spring water sample. I'm going to add a little bit to the tap water sample and a little bit to the purified water sample. That's it. Now all I have to do is stir each one. Do you see something happening? Look at this one. This is our tap water in Lafayette. And here's the purified water. Can you all tell the difference between the three of them? The spring water is very cloudy. There was a reaction between the water and the soap. Our tap water in Lafayette was a little bit better than that. There was less of a reaction because it's not so cloudy. Whenever you mix two liquids and a white or some kind of cloudy material shows up, chemists call that a precipitate. When you look at the purified water, you don't see any of that. In fact, it stays clear. This is what pure water should look like. Well, you probably got your results now. Let's talk about what it was that was actually happening and why do we have that cloudy stuff forming. Let me give you a hint. That cloudy stuff, that is soap scum. Let me show you what a soap molecule looks like. Okay. A soap molecule is basically like a lollipop. It's got a head that happens to love water, and it has a very long tail that happens to love fat or grease. So, water loving, fat loving. The reason why soap really works well when you have to wash that lasagna grease off your pan is because the tail hooks up to the grease in the lasagna pan and the head gets washed down with water. That is how soap works. Now, the problem is when you have a lot of minerals in your water, specifically the elements calcium and magnesium, they start binding up soap. You know the heads that are supposed to hook up with water to be washed away? They block those from being able to hook up with water. And so what you're left with is a soap that can't go anywhere. When it sticks around, that's what makes your soap scum. We hope you enjoyed today's lab, and I hope you learned something about the water that comes out of your tap. Until next time, this is Caroline Suyuki signing out.